Alright, see Lindelof videos, derivative of a natural log function. I'm going to start with the really easy and say that ddx of ln of x, is equal to 1 over x for x is greater than 0. Something that I want you to really keep in mind, though, is this. If we look at this just for a second, you just need to memorize this rule, but something I want you to keep in mind is that we say here x is greater than 0. X is the argument. So people get confused, and for really good reason, because they see the x inside the parentheses. Anything inside those parentheses right there is the argument, and that argument must be greater than 0. So that's where we're going with that. Also, to say to you this, that ddx of ln of u. So you say, Charlie, what the hell is ln of u? Ln of u is anything other than x. So ln of 2x would be ln of u. Ln of x squared, ln of 3x to the 4th power, ln of the square root of something. Ln of u is equal to f of x, loosely speaking. That is to say, something more sophisticated, something more complicated than just x. And this rule was true even if it was x. It's just not necessary. And if you want to, you can ask me about it, and I'll gladly tell you. So here we have that the derivative of ln of x is 1 over x. Well, it starts out the same. It's 1 over, not x, but u, whatever your function was, times the derivative of the inside. This is just a chain rule, isn't it? So all we're saying is this. When we look at this part, right here, when we look at ln of something, we take the derivative of 1 over that thing. But then, because of the chain rule, we have to take the derivative of the inside. So we need the derivative of in here. So what it ends up looking like is u prime over u. This pattern is crucial. I hope that you'll remember this pattern, because if you do, it's going to really pay off for you, and I hope you're not sharing all the secrets with everybody else. So let's try this, for example. So let's take, for example, that's too easy. Let's take one like this. Let's find ddx of ln of x squared plus 1. So I want ln of that mess. Well, remember, it's going to be 1 over, this is u, right? Whatever is the inside part is u, over u, times u prime. And the reason I put it over 1 is because I want to put these things together. We're going to get this pattern, this ln pattern, and it's going to help us with integration. And you're going to see how we can do this and undo this. It's going to be really cool. So stay with me. So as I take this derivative, 1 over u, so 1 over, and I said u is whatever is inside this box. So, sorry, what's inside this box happens to be this crap here, right, in these parentheses. So x squared plus 1, right, times the derivative of this inside piece. Well, what's the derivative of x squared plus 1? And I hear you, it is 2x. So now hopefully you can see that the reason that we did this is this. So x squared plus 1. So this is our derivative. All right? This is something that we can really do. I want to show you this just because people get freaked out. They're not sure how they're going to do this. In the case that you get a question like this, you're asked to find ddx of ln of x cubed. Well, we know, don't we? We know that ln of x cubed, we know because we have reviewed the rules of the properties of logarithmic functions, we can roll this back. So what we're really being asked is this. We're really being asked, what is the derivative of 3 ln of x? Right? And that, of course, is 3 is our constant multiplier, and the derivative of ln of x is 1 over x. So is equal to 3 over x. All right? So hopefully this is making some sense to you and it's helpful. If you have any questions or comments, please let me know. If you haven't already subscribed, please do. Thanks.